2025 is a great year for learning data science. Welcome back to a new video. In this video, we are going to talk about data science learning roadmap in 2025. I'm going to add chapters to this video. You can see the chapters from the screen right now, and also you can see them from the description or video bar. So I'm teaching data science for 3 years. I started teaching data science on Udemy, and right now I have around 60,000 students on the platform, and I started to YouTube around 2 years ago. I'm creating data science tutorials on my channel. By far I have around 250 tutorials where I cover the most of the topics in data science with real-world projects. So we are going to go step by step. The first step is going to be the mathematics. When you are going to do data transformation or you are going to code algorithms, you are going to need the knowledge of the linear algebra. Like knowing matrices and vectors is going to help you a lot on your data science journey. So I recommend learning math at the first place. So the second step is going to be the statistics. Statistics is really important because it's going to help you a lot on the modeling side and the data analysis side. So for example, when you're doing modeling, you need to know the correlation for the time series side. Otherwise, you are not going to know what you are doing exactly. So I highly recommend learning statistics as the second step. At the third step, I'm going to talk about SQL. SQL stands for Structured Query Language, and it's used for managing, querying, and manipulating the databases. And it's really important if you are dealing with any data process, because in general, 70% of the time, you are going to be dealing with relational databases. And most of the companies use SQL for the data storing, so you need to query the database for retrieving the data that you want. At the first step, learning to create simple databases, data tables, or learning to create simple queries like with select, with where, having clauses is going to be more than enough. Our next step is going to be picking a programming language. In this phase, you can select both Python or maybe even Julia, but I recommend Python since it's the industry standard right now. In most of the jobs that you are going to apply, you are going to need the knowledge of Python, and if you go through the LinkedIn or any job search website, you are going to see that most of the jobs requires the knowledge of Python because it's super easy to use. It's like the plain English. And also it has one of the biggest communities for the data science, like the open source tools that it provides. For example, PyTorch maybe or Pandas is going to be super helpful on applying data science concepts that you learn in the theory on the coding side. Also, it integrates really good with the other softwares. So when you build a predictive model, for example, a machine learning model, you are going to integrate it easily with other programming language, or even it can be coded through Python. And we are going to talk about these open source tools in the learning path. But firstly, we are going to talk about the Python programming language. So at the start, learning the core concepts in the Python programming is really important because, in my opinion, for being a good data scientist, you need to know at least good level of programming. Like at the programming side, you can do a lot of things with data science. Like if you create a machine learning model, and let's say that you have a software development team in your company and you need to serve your machine learning model, but if you don't know the coding well enough, then you are going to need to have someone to imply the machine learning model you create to their software. But if you know the programming side good enough, you can serve your model with cloud services or with APIs. Even a simple endpoint is going to make a lot of difference in the scenario. Learning the Python basics well is going to help you a lot through the process. For example, you need to learn conditional statements, loops, exception handling, unit tests, and writing efficient code well for being a good data scientist. Again, in my opinion, you are going to need these concepts in both creating programs by yourself and also creating machine learning models. For example, in the deep learning side, you are going to need the knowledge of classes, and you are going to need the knowledge of for loops for training models and creating neural networks. So after learning the core concepts of the Python programming, our next step is going to be the pandas library of Python. We use the pandas library a lot for data cleaning and data analysis. With pandas library, we have a lot of built-in methods for doing data analysis and data cleaning. So it's going to help us a lot on the starting of our data journey. Let's firstly talk about the data cleaning side. In real-world datasets and databases, we are going to have a messy data. Like in the internet, you see the cleaned data, but in real world, there's a lot of missing values, outliers, and stuff like that. So as a data scientist, you need to handle these situations and you need to clean that data for the analysis. And in the first step, you are going to be using pandas a lot for the data cleaning side. So it's going to be our first library that we are going to learn. Next step is going to be the data analysis. So for the data analysis side, we are going to be using pandas a lot. Like in the data analysis side, we can do like group bys, which is a method that we group our data by some values, use an aggregation function on a feature. Like let's say that you have the notes of 6 classes in your school and you want to see the notes by class. So you have the classes of A, B, C, D, F, and you are going to group your data by the classes and you are going to take the average on the grade column. So you are going to do a group by operation. Or we are going to need pandas on the pivot tables or maybe in data manipulation. And as the next step, we are going to talk about data visualization. On the data visualization side, Matplotlib and Seaborn are great. Let's talk about Matplotlib firstly. Matplotlib is a great option because it has a lot of plot features, like you can create most of the graphs with Matplotlib. And at the Seaborn side, Seaborn has a lot of options for customization on the plots, and it also supports most of the chart types that you can create with Matplotlib. So I also recommend you to learn Seaborn on the data science learning journey. Next up, we are going to talk about machine learning. And in the machine learning side, we are going to talk firstly about the feature engineering. Let's say that you are going to create a machine learning model and you have features like the house information, like you have the room count, you have the location data, you have the square meter data, and a lot of things like that. And you want to predict the price based on that features. Let's say that you are going to do this for new houses and your real estate workers or your real estate company can give prices to the new houses based on your model. And in this scenario, we are going to call the things that we are going to try to predict the price as features, and the price is going to be our target column. So feature engineering, as its name, manipulating these features for maximizing the model efficiency. In machine learning, what I see is 99% of the time, the better data, the better model that you have. So with bad data, whatever you do at the modeling side, you are not going to get the best model. But if you have a great data, then at the machine learning side, even if you don't do a lot of good techniques, you are going to have a good model because your features are going to be really great on explaining your target. So feature engineering is really important because you can make your data better by adding features together or removing some of them, maybe manipulating some of them, like transforming them with scaling or even with different techniques. And this is where you are going to use statistics a lot. As the next step, we are going to have the machine learning algorithms. So in the side of machine learning algorithms, we are going to separate the machine learning in two sides: supervised learning and unsupervised learning. So at the supervised learning, you are going to have the target value with the features. As we give the example of house prices, you have the price column and you have the features of house like square meters or room counts. So you are going to know the price for that features and you are going to train your machine learning model on that prices. Like you can think it like you are teaching to a kid that when you see these values, then you are going to predict this. And when you see these values change in this order, you are going to change the prediction like that. And if you know the prices with the features, like if you have the target column, then you are going to be dealing with a supervised learning problem. And on the unsupervised learning side, let's give another example for the unsupervised learning, because house price prediction suits for the supervised learning side. In the unsupervised learning side, you are not going to have the target column. So you can think it like you have a bank and you have your customers and you are going to give credits to your customers, but you need to group them because you are going to give them different rates of interest based on maybe their previous payments or maybe their wealth. So you are going to group your customers by different segments and you are going to have different groups for giving different rates. So this is an unsupervised learning problem. And on the machine learning side, we are mostly going to use Scikit-learn library of Python. And this is a really good library for machine learning because it covers most of the traditional machine learning algorithms with the feature engineering built-in methods. So as the next step, we are going to talk about deep learning. After learning traditional machine learning, you can take a look at deep learning. Like, you don't need to know everything about deep learning, But deep learning is really important that I can tell you the most of the popular applications that we see on the machine learning side, like the ChatGPT or self-driving cars, are made with deep learning. Taking a look at deep learning and learning some stuff like maybe the general structure or layers, the components like activation functions, loss functions, how we can train a deep learning model is going to be helping you a lot when you are going to get any kind of deep learning tasks. So taking a look at it is going to help you a lot on both the interview side of the data science jobs and also in the job process. Our next step is going to be creating projects. So you learn the theory and you learn this data cleaning, data analysis, data visualization, and machine learning techniques. So what now? You are going to do projects with them. You are going to apply what you learned right now, just like you are going to do on your data science job. So you need to go step by step in here. Firstly, you need a dataset to work with. In websites like Kaggle, you can see datasets that you can work with and explore them. Also, you can check the data science projects that I share on my channel for reaching to the datasets, because I work with a dataset on that videos and I always share the dataset that I use in the project. And after finding a dataset, maybe from a video or maybe from internet, from Kaggle or any data platform, the next step is going to be cleaning that data. You are going to do data cleaning techniques on that dataset, and in the next step you are going to do data analysis. Like you are going to analyze that dataset and you are going to show some findings, like for example, if you are working with a banking dataset, you are going to say like most of the credit owners with more than $100,000 debt is around the age of 27 and 34. So this is a really good finding for a banking domain, for example. And at the next step, what you are going to do is you are going to do data visualization. Like you are going to visualize the data and you are going to summarize the dataset with your visualizations. And in the next step for the project, you are going to do feature engineering. You are going to try different features for creating a better dataset for machine learning. And at the final step of the project, you are going to apply machine learning techniques that you learned and train machine learning models. At the final step, what we are going to do is we are going to create a portfolio. So portfolio is going to be a whole document which is going to show the projects that you did through this process. Like at the project side, you are going to be doing a lot of projects, and now in the portfolio side you are going to be sharing them. Like you can have both like own website for hosting your projects, you can have a blog website, or you can use something like Medium. Think of two resumes, one with no projects or no portfolio and one with full of projects. Like let's say that you have projects on different machine learning algorithms, you have projects on advanced data cleaning, so you are going to be in a better situation with your resume compared to the others who doesn't have portfolio. We talked about mathematics, statistics, data cleaning, data analysis, data visualization, feature engineering, machine learning, and we talked about doing projects with building a portfolio. With the steps, you are going to be ready for your first data science job. And I have good news for you. For all of these steps, I have tutorials in my channel. For example, in the screen that you can see right now, I have the data science full courses and projects playlist, where I have the videos for statistics, data analysis for pandas or other libraries, machine learning tutorials, real-world data science projects, and a lot more. So you can check that playlist for learning the concepts that we talked in this video. Thanks for watching this video. Have a great day.